So this is a widget. We're all familiar with this. We've seen this on the home screen. But that's a little bit boring. Don't worry, we can get rid of the background. That's better. Now we've got one with no background entirely and one with a frosted background. Of course, you can move them around the home screen and resize them dynamically. They all still fit in with the background. And I'm about to show you how I made this possible. There are some exploits in WidgetKit to do with how they render static objects, allowing you to do this everywhere in the system, and I think it looks perfect. So I think the best way to explain this is for me to tell you how WidgetKit renders your widgets now, and then I can go on to explain how I've changed that and how I've swizzled some of the parameters to maybe remove the background and do some other things that you can do. So the way WidgetKit works is slightly different to other parts of the system where you write SwiftUI. The way they render it is they actually compress it down in a pipeline to then show it on the home screen, so your application is not actively running when the widget is being shown. But that is where the exploit comes in. So these are the core steps. So you sort of have your widget that you render in your application, you design it how you want, you give it the looks, whatever. So I've given it the weather icon, and then it goes from there. And then it's compressed. So the system compresses it down into essentially what is a string or a binary string or whatever that they store somewhere, such that they can re-encode it back to the widget that you generated, and that's essentially what happens on the home screen. This allows you to send the pipeline of widgets so that you send, say, the next 4 days worth of widgets or whatever it might be. That's how this works. And that way, of course, they can send them between Macs and iPhone and to your car now and all that sort of stuff. All the places that you can see widgets. They're using the fact that they can be compressed and then decompressed, which I guess is a strong advantage of SwiftUI. Given what we now know about how widgets are rendered, we know that we've got these 2 steps. And it's at these 2 steps where we're going to be able to make a difference. With the changes added to allow you to put widgets on the home screen, they've natively added the support to remove backgrounds. And well, Apple themselves don't even comply with this, as they have a widget that's called App Suggestions, something like that, where it suggests your latest apps, and it blends natively with the home screen. Of course, accessing those is a bit harder. Apple, like Apple, do stuff slightly differently for their APIs and stuff, so that sometimes we can't access as developers. But what I thought about is, if we can run code in the app, why can't we run code in the compression of the app's widgets? And well, it turns out you can. Using some Objective-C swizzling, I've been able to swizzle the compression to tell it to remove the background or blur the background, and there are some other things you can do, although I've not implemented them. So let's get into how I've managed to work this out. So here I am now in the project, and when we're building an application like this is just a basic application. I've just given it an icon of the sun, and I've defined 3 different types of widgets. We've got a blurred widget, a clear widget, and a normal widget. I have been playing around with an analog clock. I don't know if you've seen Bryce's video where he shows you about the ability to build a clock, but that one was quite cool, and that inspired me to show you this video. So what we need to do here is we need to jump into WidgetKit and Widgets framework. To be able to do that, we need to have access to the framework, and all of these frameworks are stored in what's known as the DLL shared cache. This is a sort of speed improvement that Apple are trying to do by putting all their frameworks in there to hopefully improve the speed of the system. You can get that binary downloaded if you download a restore file or an IPSW file from Apple's website. There is also this IPSW package, which is what I used, that allows you to download the binary and then extract the DLL shared cache. So I'll show you this, though I've done it now, I'll just show you the commands in case you want to follow along at home. So I downloaded the latest IPSW for the iPhone 16,1. That is this command here. That's pretty simple. It took a while, it took 13 minutes to download, but it downloaded perfectly. The next thing that you need to do is extract the DYLD cache. So I just said that I wanted to extract that and the location of the IPSW file. And it's now extracted all of that. So we can look at that. However, you might discover that this is not very useful. So I've opened it up in Hopper, which is the disassembler that I chose to use, and I'm looking for the function that we want within WidgetKit. So I'm in the WidgetKit export object. And well, it's quite clear that this is not in a readable format of any sort of sorts. this can't even generate any pseudocode. That's because the code has been written in Swift, and the way Swift is compiled when it's compiled down makes it very hard to reverse engineer and look at. So that's a bit of an issue. But not to worry, I happen to have done all of that, so we don't have to look at all of that. If some people are interested, do let me know and I can show you that, maybe put it on the GitHub repo. Oh yeah, all of this code is on the GitHub repo that will be in the link description if you are interested. So given what we know about the code, we need to be accessing an export object. This export object is here at this path, which is saying that it's within WidgetKit and the widget extension's XPC server, and then the export object. This is just a way for the communication protocols to happen within iPhone. And well, we can swizzle that directly within our Swift application. So I've imported some Objective-C code. That's because unlike Swift, Objective-C has the ability to run something on load. We've got this export object get current descriptions with completion swizzle method. So essentially what we're going to be doing here is we're going to be swizzling the archiving and unarchiving of the widget to set custom parameters in the archived object that we can't do from the application. Of course, potentially we could expose this as an upward chain to allow us to control this dynamically, but for now I've just done it so that I set the kind of widget it is, and that changes what it looks like. So this is our swizzle method. Essentially what we're going to do is we're going to take in that class, and I've had to define the class using a string because the class is not available to Xcode, but it will be available at runtime. So we take in that class and then we're going to call this origin function, which essentially is going to allow us to look at some of the parameters in the encoding and decoding and call different parts of the encoding parameter set that we need and extract the parameters. So in this code we generate a custom class with custom init with encoding that supports secure encoding. Secure encoding is required as that's how they render the widgets. So we're going to do all that sort of stuff here with the description up here, and we're saying what type of objects we're looking at. We're going to be looking at an NS array for activity descriptors, so activity widgets, control descriptors, widgets that exist on the control center and on the home screen, and widget descriptors, the standard widgets that you would expect that we are now swizzling. So what we're then going to be able to do is call a custom init with encoding, where we're going to extract these encoded descriptions of the classes, and now we can see all of the widgets that we are returning back to the application. And well, we're going to do a little bit of swizzling with this. This is where we're actually going to do a lot of the work. We're going to look at that widget class group, and we're going to actually say, if the kind of that widget is, say, my clear widget, so you want it to have a clear background, we're going to set some custom parameters of set background removal to yes, set transparent to yes, and set preferred background style to 0x1. Of course, if we wanted to have a blurred background, maybe we want not clear, not perfectly clear, but we want a bit of an ambience there. This is kind of native now in iOS 26, so we might not need this anymore, but you can set a blurred background, which is just saying that it's got a transparent background, and we're setting its preferred background style to 0x2. And that's how that works. We're then generating a new array because we've got a mutable array. We've been able to update the objects as we've been editing them. And then what we do is we just release them back to the system as if they had been securely encoded. We now continue the rest of the encoding pipeline as if it was running natively within the system. And that is it. My widget now has no background. So now let's take a look at it on the iPad. So as you can see here, I've got my standard widget with background. If I make this slightly bigger, of course it expands. But then I've got my two other widgets. Of course, the size of the widget still impacts the area that it will take up. However, the background is natively clear, and when moved around the home screen, it natively blends in with the system. And well, that kind of sums this one up. You can add the widgets like you normally do in the widget gallery and expand them and contract them like you want to. And well, this is a little trick on how exporting a function somewhere in the system can be used somewhere else to maybe trick something into doing what you're doing. Apple, of course, don't want you to do this, but it's a nice little trick for your friends and family, and well, I think it's going to give the iOS 26 home screen a nice little pop if some people come out with some clear background widgets. But anyway, I'll see you in the next one.